Okay, well, welcome. And I just do a couple of slides about me, okay, and then I'll tell you where I'm coming from and the technology that we're going to talk about today. So that's me. Old guy, okay, gray hair, white hair, no hair, okay. Teeth are going as well now. That's the nature of technology. So I'm quite fortunate. Done pretty much everything in my IT career. Started life as a developer. I've done pretty much everything since. So was a researcher as well, consultant, technical marketing, big data, lots of things. And so two companies that I would draw attention to in particular. The very first company I worked for was Reuters in London, working on real-time systems, relational databases. And first 8 months there, worst 8 months of my life. They got me working on RSX11S, RTL2, PDP11s, you know, these things had switches. So these things were old even when I joined them, you know. But the thing is, after 8 months, I kind of understood why Reuters kept this old technology. There is business value. Someone has to care for these things. Someone has to love them, right? The other company that I draw your attention to is Infomix. So at Infomix, I had the great privilege to work for Mike Stonebreaker. So if you know anything about database systems, Mike is the guy who invented Ingress, Postgres, Vertica, SciDB, VaultDB, Tamer, ... This goes on. Okay, fabulous gentleman. He won the ACM Turing Award a couple of years ago. So it's like the Nobel Prize, all right? Wonderful gentleman. These days he's at MIT, still active in research, but obviously slowed down quite a bit since the early days. A couple of years ago, then I got into the big data space. So I worked for Hortonworks and also for DataStax. Was an independent consultant. And then about a year ago, GridGain came to me and said, look, we'd like to offer you a job. I said, great. So what does it entail? What do you want me to do? They said, we want you to go out, present at meetups and conferences, talk about Apache Ignite. And I thought for a minute, I thought, I don't know anything about Ignite. They said, we'll teach you. I thought, great. And so Ignite is open source. More about that shortly. And so I've got the best job in the world. So someone pays me money to talk about open source, right? How cool is that? You know, that's wonderful. Other stuff, so as I said before, worked lots of different technologies. Started years ago working in assembler and process control languages. Subsequently worked in C++, C, Java, various IDEs. Publications, presentations, so I've been very fortunate in that put together some books. So these make wonderful gifts for family, friends, loved ones, birthdays, Christmas, any time of year, okay? Seriously though, don't buy any of these. Look at the titles. Object-oriented databases. Who uses them? Nobody. XML databases. Who uses them? Nobody, all right? What's the hot thing today? NoSQL? MongoDB? All right, 10 years, nobody will be using them, all right? Containers? All right. I will hedge my bets here, okay? But 10 years from now, I bet you something else will come along, okay? So this conference, if it's still running in that time, probably talking about something else, right? I mean, that's the nature of technology. New things come along all the time. Sometimes they replace what they already have. Sometimes they are complementary. So if you're interested, as I said, I knew nothing about Ignite. I knew nothing about in-memory data grids when I started with GridGain. So my boss, Dennis Magda, so Dennis is the PMC for Ignite at Apache. He said, why don't you blog, write some articles, talk about what you learned. And so if you have a look on DZone, there's a bunch of my articles. So the early ones were very kind of basic. More recently, especially this year, focusing on a lot more sort of technical aspects, things like failover recovery. Did something on containers late last year, you know, how to deploy Apache Ignite on Kubernetes on AWS. And that was quite a challenge because I couldn't find the information, you know. Kubernetes is hot. The technology is fabulous, but the documentation is awful, you know. It's terrible. As a community, I think it's very important to have great documentation as well, because for people who want to learn and for people who want to use this stuff, they need to be able to find the relevant information at the right time and be able to work and be able to deploy, you know, run these systems in production. So it's not just a great open source project, but it's a great open source project that you can use for building things, okay? At the end of the day, technology doesn't matter, seriously. I mean, what it is what is the business problem you are trying to solve, right? Are you trying to make more money? Are you trying to be more competitive? Are you looking for threats, opportunities? You know, these are the kind of things that people worry about, okay? All right. So, let's switch to the main presentation. All right, so any of you using Apache Ignite? Have heard of it? Okay, a few of you, great. So, as I said, part of my job is to inform and get you to have a look at the technology. It could be very useful for you. And then particularly I think with Kubernetes, okay, so this is a great kind of environment, if you like, for deploying a range of technologies. Some of them you've heard about today. And Ignite is just another technology in your toolkit, toolbox, something that will give you the opportunity, perhaps for some business problems, to make it quite usable and quite useful. Okay, so in terms of agenda then, so I'll talk a little bit about what Ignite is, okay, and give you more information about where it's coming from and why it might help you in certain problems. And then we'll walk through some simple steps. Okay, so it's really just a couple of YAML files. So as I said before, one of the articles I did last year was how to deploy Ignite on Amazon Web Services using Kubernetes. So 90% of that article is just getting Kubernetes working on AWS. Okay, the last 10% is Ignite. I mean, really, really simple. Okay, series of YAML files, very easy to deploy, and I've actually got Minikube running on here and just show you how this is done. Okay, so the big picture, 30,000-foot view, as they say. At its core, then, Ignite is a memory-centric database. Originally started life as an in-memory data grid, okay, IMDG. Perhaps you are familiar with some other IMDGs, some commercial products, some open source products, Oracle Coherence, for example, or Hazelcast, okay? So these are the same sorts of technologies. Especially this last year, they focused on a range of capabilities to really extend Ignite in a variety of different directions. So one of them is this native persistence capability, okay? So rather than keeping everything in memory now, Ignite can persist data using its own persistence capability, okay? Very useful. It can work with third-party systems as well. And these can be transactional, relational database systems, typically, or could be NoSQL, HDFS. If you're working with transactional systems, one of the nice features and capabilities of Ignite is that it can manage the cache and the back-end relational system and keep the two consistent, okay? So if there are changes propagated to the back-end relational system, those are reflected in its cache. If you change things in the cache, those get propagated to the back-end relational system, okay? The two things are kept in sync. And one of the reasons why Ignite came about was to address this issue of performance. Sometimes relational systems, and I think that the previous speaker kind of touched upon this, you know, you may have a relational system. Relational systems are great kind of generic database systems, great for a wide range of problems that you can use them for, but sometimes you may hit some performance issues. To give you an example, so earlier this year, I was in Brussels, and there was a gentleman who was, he mentioned his particular use case. So they've got Postgres, and they use it for a wide range of business problems. For the vast majority of use cases, it works perfectly fine. But they have some performance issues in a couple of cases where they're looking to really scale up and address those performance issues. So they're looking at Ignite as a way to act as a cache, to use cluster computing to scale up the performance. And so there is business value in their system for which they are not going to get rid of Postgres, okay? It's very important to their needs, but at the same time, use Ignite for enhancing and improving performance in certain cases where their existing system cannot perform. The other thing, some of the other things that supported last year, SQL 99. So there's a big effort. So Ignite has always had some level of SQL support. Now, you may like SQL or you may hate it. The truth is that it's intergalactic data speak, okay? That's life. Lots of BI tools, enormous amounts of skilled developers are available who are familiar with SQL from a variety of different platforms. So finding people who can use SQL is very, very easy. At its heart, originally as an IMDG, it was a key value store. And again, you may be familiar with other key value stores, such as Redis, for example. So Ignite is very capable in that the value can be anything. Okay? So it can be simple types, can be complex types. For example, could be a financial instrument, healthcare record. And then what it uses is just hashing. So it takes the key, applies a hash algorithm, and then it knows which particular node in the cluster will store the primary copy of the data, right? And it's a peer-to-peer system. There is no master. Typically, in distributed computing, what you will do is you will create replicas. You know, distributed systems can be unreliable sometimes, you know? If we're using commodity hardware, chances are some nodes are going to fail, right? But if you've got replicas, backup copies, then it's okay. You know, you just revert back to these. Ignite also does transactions. And so these are both pessimistic, lock-based transactions, and optimistic, lock-free transactions. Okay, so different use cases for these different types of transactions. So I'll give you a great example of why this is useful. So about 50% of the use cases for Ignite are in the financial world. That's where a lot of organizations are using it. They need consistency, okay? And transactions can give us that. So we want our system to move from one consistent state to another consistent state. And let me give you an example from real-world experience. Slightly tangential, okay, but very, very relevant. So I'm a great fan of MOOCs. I like these massive open online courses. Earlier this year, I was on the website of one of these. And there's a particular course that I happen to like, and I think, okay, I would like to pay to get the certificate for this course. So I get my credit card out, put in the details, hit the pay button, and it comes back and says, there is an error. Okay? So I didn't think too much about it. Okay, there's an error. All right, transaction didn't complete, not a problem. Sometime later, I look on my bank statement, and I notice I've actually been billed. I go to the merchant, and they say, we haven't received the money. So where's the money, you know? And I'm kind of left in the middle because the bank is going to charge me, but I haven't received the service, okay? Now, there's an example of a very poorly designed system, all right? What should happen is that the transaction should complete, I should be correctly credited and be able to take the course, receive the certificate. We can't have this situation, you know? It's like if you're transferring funds. So if I send you, say, 1,000 euros, my bank account needs to be correctly debited. Your bank account needs to be correctly credited. We can't have the situation where, you know, one of those actions, the first one happens and the second one doesn't. The system needs to move from one consistent state to another consistent state. Okay, so transactions very, very useful. Other things, so compute services. So Ignite can form the foundation, if you like, of a microservices architecture as well. We have some information on that if you're interested. Streaming, so if you're working with technologies such as Flink, for example, or Spark streaming, Ignite has adapters and connectors for these technologies. So it doesn't provide streaming natively, okay, no need. Plenty of good streaming engines out there. And the last thing, of course, because everybody's doing machine learning, Ignite is doing it as well, all right? It's just one of these things. Lots of verticals. Have a look on the Apache website, okay, and you'll get plenty of examples of these, okay? So hopefully that's a kind of a good kind of broad overview of what Ignite is. Okay, so it's very capable, very versatile. Think of it as a little bit like a Swiss Army knife. Okay, so range of capabilities and components, and these are integrated. Okay, so the whole is greater than the sum of the parts. That's one of the nice features. So one kind of use case might be, say you're using Ignite as a sink for IoT streaming data. So you can define windows, say the last 10 events or last 5 minutes worth of data. As that data arrives, because it's very fast, okay, can cache things across a cluster in memory. You can run SQL on that data very, very quickly. You could apply some machine learning on that data very, very quickly. You can do things, okay? So once the data is thrown away, again, you're waiting for that next batch of data to arrive. So there's a whole range of things that you could use this for. Okay. So moving on then, two main types of nodes that we have in Ignite. Okay, so server nodes. This is where the processing takes place. This is where the hard work is done. But we also store data as well, okay? And each node is holding a portion of the data across the cluster. Visually, we have a cluster displayed on the right-hand side. So typically, we're able to run compute tasks. We've got our data. And again, if we want persistence, native persistence capability, it's just a flag that we can enable. The reason why they've added this capability is normally it's highly unlikely that you're going to cache all your data. If you, say, have like a petabyte of data, probably you're not going to cache all of that, unless you're Twitter or Facebook or someone like that. Okay, those guys tend to have very different requirements from the vast majority of users. So your cluster, each node may have, say, a terabyte. Okay, so you can cache a certain amount of it. What gets used frequently, that makes sense. The thing is that with caching technologies in general, if you pull the plug, the cluster goes down, the data's gone. You've lost state. Right? So this is where the native persistence is a very useful capability. You can bring things up very quickly and restore state. Client nodes just simply connect, request operations. There are other service nodes as well, which are not shown on here, but these, again, can be a foundation for things like microservices if you want to do that. That's perfectly possible. Other things. So in terms of deployment, Ignite's written in Java, okay? So it uses JVM. And we could configure it in a variety of different ways, how many nodes we want to run. Very easy to do. The other thing is that it will run pretty much anywhere, okay? So cloud-based environments, I've got it on my Mac. If you've used any of these kind of small Raspberry Pi type computers, it will run on a Pi as well, all right? So a few months back, I had actually a Raspberry Pi, my Mac, networked together, each of them running an Ignite node. I had a cluster, okay? It's one of these things. Now, the thing is, with these kind of small devices, it can be useful. So again, earlier this year, I was at a conference in the United States where a gentleman was telling me that he's developing this kind of weather service. So he's looking at small computers located in a distributed environment, and typically that's kind of a Pi type of computer. So everything is self-contained. It runs, can be remotely managed, but running things like Ignite, for example, gives certain benefits as well. So it's something that he's looking into and developing. And the other thing is, of course, containers as well. So Kubernetes, Mesos, Yarn, and others are available as well. When you're running a cluster then, typically a very important requirement is that nodes need to find each other, right? So you can power up the nodes. This can be done in a variety of ways, okay? So either through multicast, static IPs, or in Kubernetes, we can do this through an Ignite service, okay, which I'll show you in just a few moments, okay? So there's a variety of things that we could do. Okay, so cluster discovery, node IPs are unknown, IP addresses change after restarts, so this is where this Kubernetes service is really going to be very useful. you get all the benefits that you do of cluster computing. So peer-to-peer, self-healing, self-contained, based on Ignite facilities. Okay, so these are fairly standard kind of capabilities in terms of scale, deployment. As nodes may go down, for example, for various reasons, hardware problems, or perhaps parts of your cluster are no longer available through some latency issues, or perhaps some network issues, then Ignite will recognize these problems, and it will follow the set of rules and configurations that you've decided that you want to do. So it will replicate data appropriately. Things like rack awareness as well, all built in, very capable. As far as the Kubernetes deployment is concerned then, so there is a lookup service, okay? Because obviously, nodes need to find each other, and they've done through this particular service. So it's an IP finder, okay? You need to have this up and running so that as these nodes come up, they can use this lookup service to be able to find other nodes and then be able to join the cluster as appropriate. Fairly simple to do. Okay, so there's just a simple example of this YAML file of how we might actually do this. And then in terms of the actual Ignite deployment, again, very, very straightforward. Okay, so examples of these are available in the documentation. Scaling, perfectly possible as well. Okay, so this is this example I've tried before on my Mac. Unfortunately, because it's a little bit underpowered, it tends to grind down considerably. The performance is not as good as it could be, but in live and bigger environments, okay, this will be just fine. Okay, now, I'll show you a demo, but what I've done is sometimes, as you know, if any of you have some experience with Minikube, you'll know that perhaps occasionally it tends to falter a little bit, or tends to be a little bit slow. So let me just show you a couple of the screenshots in terms of what I've done, but it's actually, fortunately, up and running on my local Mac here. So just simply starting this up, okay, just using the Xhive driver. I know it's deprecated, but for these purposes, it's fine, okay? So it works just fine. That takes a few moments to actually get up and running. Here, what we've done is simply create an Ignite service. Okay, and then there's some permissions issues, role-based access control that we need to configure as well. Okay, that's a kind of a recent thing that otherwise it's not going to work. And then there we can just see where this is actually running, where the service is running. Okay, support 9042. And I think the previous speaker talked about, volumes, claiming volumes. You have to use that approach. Currently, persistence capability is available, but I'm sure, with the kind of capabilities and the directions that Kubernetes is going in, the Ignite development team will take all of those into consideration. Okay, so it will be added in as required. So usually it's this process that takes a little bit of time to get going. I was fortunate enough to actually have this up and running a little bit earlier, which I'll show you in just a moment. Okay, so let's just switch out of here. Okay, this is meant to be standalone. As you can see, this has been running for over an hour now, fortunately. So I've got 2 pods running, well, 2 hours now, okay? Occasionally, and someone can, educate me on how to use this properly, but I find that Minikube is great for a kind of standalone environment just for demo purposes, and if you want, something that's quite portable, you don't have to connect to a cloud-based environment to get this running to show things. But the problem is, it seems to want to connect to the outside world for something. I mean, occasionally it's trying to get, and some ports are occasionally blocked as well, in which case it ends up being a little bit embarrassing because it doesn't work. You're trying to show a demo, it's entirely supposed to be standalone, but it doesn't work. Anyway. Okay, so we've got a couple of pods running, okay, and then all I've done is I've got the dashboard fired up, as you can see, a couple of deployments there, all right? So 2 pods, and if we drill down into one of these and have a look, we can have a look at the log. Okay, so there we have an Apache Ignite node running. As you can see at the bottom there, okay, it tells you, okay, so this was the one that launched first. And as the second one came up as well, the two of them have found each other, okay? So we do need that IP finder service running for this to work. Otherwise, these things just can't discover each other, right? Okay, so that's very straightforward. All right, then we can go back. And I think if we can have a look at the other one in the other pod. Let me just drill down here. Just again have a look at the logs. Okay, there. Okay, so here you can see this was the second one. So it does tell you that there are 2 servers, 0 clients, CPUs. Okay, and these are just defaults. Okay, it's all configurable and based on what sort of resources you want to assign. And these things are fairly easy to up and running. The other thing I will add that although, as I said, it's a Java-based system, you can use C++ and .NET, okay? So they are also top-level languages that are supported. If you're working with something else, Python, Ruby, something like that, JDBC, ODBC, okay, is the way to access those at the moment. All right. So let's just switch back here. Make sure this is done. Okay, there we go. So showed you that, showed you that, showed you that. Fairly easy to shut down. Okay, so I think just to give you a little bit of information. Okay, so this is the homepage for Ignite on the Apache website. Plenty of information in terms of Kubernetes through the documentation. Okay, you can read about that. My boss, Dennis, he's just working on some additional information about persistence. Okay, so the last speaker talked about a range of persistence options. You know, we've got something to say on that matter as well. And I believe it's amongst the top 5 most active Apache projects at the moment. So that's both in terms of contributions and activity on the user and dev lists. So by all means, you know, sign up, participate, contribute, and I think there's lots of information that you get. There's an awful lot of great contributors on there. So even basic questions that people ask about how to use some features of Ignite, for example. Sometimes, again, it's not clear what options there are, because if you have a lot of sort of possibilities in terms of how things can be configured and set up, it can be a little bit confusing, particularly if you're sort of fairly new to the technology. And so I'd encourage you, sign up for the dev list and the user list, participate, and there's an awful lot of very, very knowledgeable people that will assist and get you started. Just 2 other things, I guess. So if you wish, by all means, reach out to me. Okay, so it's just first name dot last name at gridgain.com. So Akmal Chaudhri at gridgain.com. I'm on LinkedIn. If you're social, I'm on Twitter. By all means, reach out and feel free to connect. Okay. So I think in conclusion, what I'm trying to show you there that Ignite gives you another option in terms of managing your data. Okay, it can give you persistence capability. If you've got existing systems that you need to work with, transactional, non-transactional, it can work with those. Scale and performance are the 2 kind of main things that it gives you. It's cluster computing, all the kind of things that you would expect of cluster computing in terms of failover, recovery, replication of data. All of these are available. But it does far more than just caching, okay? So supports transactions, SQL, range of other features as well. You can deploy it and run it in a variety of environments, of which Kubernetes just happens to be one. And so really, hopefully that will give you, an opportunity to think about Ignite as a potential for something, for some future project that you have. Okay, fabulous. So I think I'm done. And I believe I'm supposed to throw one of these out to the first person that asked the question. So, anyone have any questions? Okay, there we go. Okay, I'll try. Fabulous. Great.
So the cap theorem claims that you Hello?
The CAP theorem claims that you have consistency, availability, and performance, and you have to sacrifice one of them.
Yes.
Which one sacrifice Ignite?
Okay. All right. So the gentleman was asking about the CAP theorem. Okay. So the CAP theorem, Eric Brewer, very smart guy, professor, and also does consulting for Google. He came up with this theorem which says that in a distributed environment we have consistency, availability, and partition tolerance. Okay. These are the three things that we have, and typically a distributed system can do two of these, but has to sacrifice the third one. So in Ignite's case, it sacrifices availability. Okay, so it will go, but the thing is that you can do things to mitigate that. Okay, I mean there are a range of features that it has, so it will go for consistency and partition tolerance, but sacrifices availability. If you're interested, there is a gentleman out there, Kyle Afer, who does a lot of this sort of testing on these distributed environments, and he pushes them to extreme limits, and people pay him huge sums of money to do these tests. He's got an entire website, and I think many of the NoSQL products, MongoDB, Cassandra, even IMDGs such as Hazelcast, he has tested these for exactly the kind of scenarios that you would get in a distributed environment, and which elements of the CAP theorem do they actually adhere to, and which one do actually fail. So it's worth having a look at. Okay, any other questions? Yes.
More a shameless plug than a question. Instead of Minikube, you could use Docker for Mac or Docker for Windows to run a single node cube.
You need to talk to my boss and persuade him to get me a bigger machine, okay? I'm constantly fighting this thing. Docker is great, and there's a whole bunch of things I wish I could use, but sometimes the technology limits what you can show. And what I tried to do today was show the simplest thing I possibly could without running into memory problems. But thank you very much for the suggestion.
It should be a little bit more performant than Minikube.
Okay, yeah. Great, thank you. Okay, fabulous. Well, thank you very much. And you've been a wonderful audience, thank you. And as I said, reach out to me if I can help. The slides will be available later as well. Feel free to connect socially on LinkedIn, Twitter, Facebook, any of these mediums. Just search for me and you'll find me. Okay, great, thank you.